I'm Dave. This is Jason Party here. We both work on the geoprocessing team in Redlands. Today we're going to just talk about the new arcpy data access module, which is something new that we're starting with at 10.1. This is the abstract from your little guidebooks. This module is really sort of just like a collection of things that we use to work with data, and a lot of the parts of it are things that have been heavily requested over the last few years. Pieces that have the Python solution that just were either missing or weren't efficient or fast enough. So this is, well, it really breaks into the four major pieces. So the cursors are probably the biggest one, the one that probably gets the most attention. The cursor model we had before really just wasn't fast enough. So at 10.1, we now have a newer, faster cursor. We've added support for edit sessions and edit operations into Python. This was something that wasn't possible before. We've added more support for Numpy. At 10.0, there was the ability to take rasters and convert them to and from Numpy. Numpy, of course, is this third-party site package you can add to Python. It's for sort of scientific analysis and working with large arrays really efficiently. And then there's a number of additional classes and functions for working with things like replicas and subtypes and domains. So let's start with cursors. Cursors are really sort of like a workhorse for a lot of operations, right? My background leans towards geoprocessing. You think about geoprocessing, and it's working on data, as collections, right? You're working on an entire feature class at once. Well, in a lot of other workflows, you really need to get into the feature, right? Into individual rows and be able to work on those in an iterative sort of way. That's what cursors support for us. Of course, we've had cursors with Python since 9.0, but they really just weren't efficient enough. I think we were starting to see people who were getting boxed out of Python to some degree because the speed drain on the old cursors just prevented people from really coming up with algorithms in Python. So Jason did some testing a while ago on the speed of the cursors, and this is sort of a relative look at sort of best case cursor performance increases. So 30 times faster, 12 times faster, right? That 30 times faster, that's a week versus an afternoon, right? So all right, so with cursors, we've done what we can to speed them up, but we've also given you a few options to help increase your own performance when the context is right. So anytime you use a cursor, right, you're accessing a table or feature class, and you're pulling out rows and values from those rows. If you have a very large feature class with lots of fields, right, 100 fields is a significant time hit if you're asking for everything. But if you only really need 2 or 3 fields, well then ask just for those fields, and you'll see a significant performance gain there. Another thing we've added to this is sort of a concept of geometry tokens. So there's maybe about a dozen of these, things like shape at XY, shape at centroid. If you're using a cursor and you're asking for the full geometry, you're working through a set of polygons, asking for the full geometry is actually relatively expensive, and time hit. But if you're only using that geometry for specific properties, you can use these tokens, and it'll significantly shorten time as well. This slide here is sort of more of a contrast situation. The top one here, this is the new cursors. With the new cursors, the data access cursors, we work with lists and tuples. The old cursors, the one we'll call them classic cursors, work with row objects. So in this example here, I'm just opening an insert cursor on a table and specifying a couple of fields. If I want to put values into that feature class, I do it in a list or tuple, and it's done by index. So field 1 will get value of 1, field 2 will get a value of 10, and then it's inserted. The classic cursors did work more on like an individual value. So you would open your cursor, you create a new row, and then for each field value, you'd set a value. So field 1, again to 1, field 2, again to 2, and then you'd insert the whole row object. Historically, one of the things you always had to be careful with the old cursors was this sort of database locking thing, right? When you were running a cursor, you had to sort of keep in mind, that this cursor object would be sitting around. You were, say, working in an IDE, sort of interactively kind of getting your code right, and you also were sitting over here with the data in the map. There's a potential for data locking, right? You had to be very careful about where the cursor objects were and delete them as necessary. Well, at 10, with the new cursors, we support something called with statements. So with statements are a Python statement that got introduced with Python 2.5, and it provides sort of context management. The point for the cursors being that regardless of whether or not the cursor succeeds successfully or there's some failure that comes up as you're processing, the with statement will take care of any database locking. It also actually makes it quite a bit cleaner. So the top example is sort of a convention I might have tried to use in the past to make sure that when I ran a cursor, regardless of what happened within the cursor, my database locking was taken care of. So it's quite a bit of stuff here, right? And that's in a for loop. If I just put that into a with statement in Python, just with arcpy cursor, as cursor, and then I can iterate through the cursor. There's some exception here at any point. It's going to exit out, close my cursor, delete the locks, and I can proceed with that data without worrying about a lock. Okay, I'll let Jason show some of that in some more detail.
What I'm going to do now is I'm going to walk through a number of scenarios and highlight some of the cursor capabilities. And I'm going to focus in on search cursor and insert cursor, and then I'm going to show you some of that performance gains that Dave mentioned. But before I do that, first thing I want to show you is that this new data access module is completely docked in our desktop help under our arcpy module. So you can go here, learn what the data access module is. You can see the list of functions. You can also see the classes. Now the first thing I'm going to look at this morning is a search cursor. And as you see here, search cursor takes in an input table, and you'll notice here the field names, as Dave said, are required. So what we're doing in this case is they weren't before, but we want you to think about it because performance is a big thing. And if you don't need all the fields, you don't want to access them all. Just give a list of fields that you want to access only. And this is going to improve performance as well. So we have two required inputs. We got our table, we got our field names, then we have some optional arguments, just like there was with the cursor directly off arcpy. We have a where clause. You can provide a spatial reference if you want to open that cursor in a different spatial reference. If you're working with lines or polygons, you can actually explode them all to points and get the point information of those features. And we have what's known as a SQL clause. And I'm going to use that in my first example. So a SQL clause has two things. It has a SQL prefix, so it supports a SQL prefix, and that prefix supports distinct or top. And it also has a postfix, a SQL postfix option, where you can do order by or group by. So you can get those records back ordered or grouped. So now let's go and look at some code. So in this map, I just have some water wells for the province of Newfoundland in Canada. What I want to do is I want to just look at some of the information back from that. I want to get the well depth, I want to get the community name, and I want the XY coordinates of each of those points. So I've already gone ahead and coded some of this. So I'm going to do this inside a with statement. So this with statement will actually open up the cursor, and when I'm done, it will make sure that my locks and my cursor objects, everything gets deleted properly. So inside my with statement, I'm going to open a cursor on my wells layer, and now I'm going to provide a list of fields. So I'm just putting in a tuple of fields here, and I'm using some tokens. The first one is the OID at. That will actually give me the object ID. Then I'm going to get the community value. I'm going to get the well depth. And then I'm going to get the X and Y properties of the shape. I'm not going to get back the full geometry and then ask the geometry for its X and its Y. I'm actually going to use a token here, which is an XY token, and just get those properties. And then I have a SQL clause. I'm not using a prefix, but I am using a postfix. So I'm going to order the results by community. So I'm going to order by that community field. And then for every row in my cursor, I'm going to print the OID, the community name, the well depth, and then the X and Y information. And you can see here, if I start scrolling up, I have my OID, I have my community name, the well depth, and the XY, and it's in alphabetical order. So that's one example of using a cursor. And you can see here, I'm not using the del keyword once I'm done. I don't need to delete it. Once that with statement was exited, it took care of cleaning up all the objects. So let me just clear that. Now, turn off my wells. Turn on my rivers. So what I want to do here now is I want to find the sum of the length of all the rivers. So what I'm going to do is I'm going to, again, use a search cursor. So I'm going to say with arcpy.da.search cursor. And on my rivers, I'm just going to ask for shape at length. I think that's spelled right. As rows. Now, I'm going to sum these up. So what I'm going to use, I'm going to use the Python's built-in sum function, and it takes a sequence. So what I'm going to use here is I'm going to use a Python list comp, and I'm going to say row 0. So we're only asking for one thing. So when our cursor returns something, it's returning it as a tuple or a list of values. So I'm going to say row 0 for row in rows. Let's let you see the value. So let me just rerun that. I just push the up arrow. Let me print it out. So you can see here it's roughly over 15 million meters in length of information. So you can see how quickly here, it actually summed up the length of all that rivers and how quick that was. That was really fast to search cursor through all those rivers. So let me jump over to another example. Here, we're going to jump. So that was a search cursor. So what I'm going to do now is I'm going to do an insert. I'm going to insert some points into a feature class. Here I have cities. So if you look at this cities point feature class I have here, it's empty, and it has a name field, a country, and a capital. And I'm going to populate all that information from this CSV file. So if I open up the CSV file, it has country, capital, name, and it has the coordinates for those cities. So what I'm going to do is I'll just load this rather than type it. Insert points from CSV. So the first thing I'm going to do is I'm going to open a search cursor on the CSV file, and I'm going to ask for the UTM-X, the UTM-Y, name, country, and capital. Then I'm going to open up an insert cursor on cities, and using the shape at XY token, because it's points, I'm just going to insert them as X and Y, and the insert cursor will take care of creating those points for me, as well as name, country, and capital. And then for every row in the search cursor, insert my information. So here's I'm passing the coordinates in as a tuple, and then I'm accessing and passing in the other values. Let me refresh, and there they are. So much shorter, much cleaner code than you're used to in the past. Using the with statement takes care of some of these things, deleting all the objects for you. So let's look at another example. One more example here. Let me turn on, let me zoom to this layer. So what I have here is Crow River, which outlines the boundary of Hennepin County in Minnesota. And I'm going to turn on my Python window. And I'm going to load another script. And what I'm going to do here is I'm going to use a search cursor once again. And I'm going to walk through. Now this time I'm going to access the entire shape. So I'm going to get the full geometry back. So I'm going to use shape at to get that full geometry. And then I'm going to start walking through, and for every position at 1,000 meters along that line, I'm going to put it into a list, and I'm going to create a new feature class. Oh, I got an error, and I know what the reason. So I'm going to clear that, hit my up arrow. It's the wrong layer name. It should be Crow River. And there you can see it created points at 1,000 meters along that river. So again, I'm using search cursor, getting the full geometry, and then I have operators on geometries now that I can access information. And then I just pump it into a new feature class. Okay, so let's go and look at some performance. So let's open up a new map, actually. I think I have it in my recent here. GPS to points. So what I'm going to do in this case is I'm going to run a geoprocessing tool whose source is a Python script. And what I'm going to do is I'm going to take GPS points that were captured along the Trans-Canada Trail in Atlantic Canada. And there's about roughly 30,000 points here that I want to insert into a new feature class. So let me go ahead and get this running first. So I'm going to go out and find my GPX file. AtlanticCanada.gpx. This is actually a core tool in our software now, 10.1. And let me drag in the feature class. And I'm going to let this run. Now, over in my Python IDE, let's look at the function that's running right now. And this is using the insert cursor that you have available to you today. So I'm doing arcpy.insertCursor on my feature class. And then for all the points, I start iterating. I create a new row, then I create a new point geometry from the X, Y, and Z, and I insert the row. And once it's all done, I make sure that I clean up my row objects. So that's running right now. And it's back here. We can see, because I'm timing that function, it took over 25 seconds to run, to insert those 30,000 points. So, if you look, let's just refresh here. You can see that they're there. Now, clear this. Let's go ahead and delete those points. Delete those. Now, let's actually comment out this function. So we're going to comment that out. And let's uncomment this other function. That's going to use the data access module. I'll save it. So in this example, again, we're opening an insert cursor on our feature class, but we're going to use shape tokens. So we're going to be saying shape at X, shape at Y, and shape at Z. We're inside our with statement, and then for every point, we're going to insert row. So we're inserting X, Y, and Z. You notice I'm not deleting anything at the end or anything like that. I am going to refresh my active view in this case so that you'll see the points automatically. So let's look at now rerunning this tool. Let's again go to get our GPX file. Put in our feature class, and we'll hit OK. And we'll see how long this one takes. So that function took 3.8 seconds versus 25.5 seconds. So you can see there's a significant improvement in performance. So that's one example of that performance improvements. And that's it for this demo. Dave, back to you.
Yes. So one key note there. I mean, at 10.1, you don't have to go back and update to use the new cursor, right? Everything that was there before will still continue to work. But I think in examples like JSON, right, there's like a very significant difference in the time, right? It would be worth at least going back, any cases where time is important and you're using cursors, and just review and make some changes. And it's not keep in mind too, it's not just like a swap in, swap out, right? It's not, can't just put arcpy.da, search cursor in place of the old one, right? There's some signature differences. You're working with lists and tuple versus rows, but it would definitely be worth reviewing. Another big thing that we've done here at the data access module is working with the editor class. So this gives support for edit sessions and edit operations at 10.1. So of course, the way edit sessions work, right, is that they're temporary until you've explicitly committed them. And so at any time too, right, you have the option of quitting that edit session and discarding any changes. So there's a series of methods that are supported on the editor class. Things for dealing with your edit sessions and your edit operations. If you work with arc objects already and you've done edit sessions before, this will look pretty familiar. However, well, I'll get to my point in a second. Sometimes you just need an edit session, right? There's feature classes that participate in a topology or geometric network. You can't just edit them as is, right? You need an edit session. Version data sets in an ArcSD geodatabase, you need an edit session. And there's just some objects and feature classes, class extension, where you need it too. So going back to all those methods on the editor class, I mean, they're there, but we also support with statements on the editor class. And it handles all of those sort of calls for you. You can, if you need the fine-grained control to work with the operation, abort, undo, these things, you can do that. But the editor class and a with statement, you use the with statement, you're opening an edit session, and you're starting an edit operation. Within that with statement, if something goes wrong, there's some kind of an exception, the operation will be aborted and the edit session will be saved, and you're closed without saving. But there are no exceptions. It'll just stop that operation. It'll save and close your edit session. All right, I'll take that back to Jason.
Okay. Let's talk about the editor for a little bit here and show some examples. But again, I want to start with the help, because the help talks about all the behaviors of editing, file geodatabase as well as STE databases. It's a very similar model if you've been editing data in the past with arc objects. So keep that in mind. If you've edited data before with arc objects, it's going to be a very similar experience. And some of the functions on the editor class are going to be familiar to you. But it's worth taking a read of our documentation here, and it has some examples. So let's look at one example first of what happens when we run some of our tools. So for the rivers feature class, if I open up its attribute table, I have the name field. Now what I want to do is I want to add a new field, and I want to calculate the new field equal to the values in here. Very simple example. Maybe relevant, it may not be. But let's look at what happens when I do something and make a mistake. So I'm going to do arcpy.management add field. I'm going to add a field to my rivers, and I'm going to call it river name. It's going to be a text field. I'm not worried about precision. I'm not worried about scale. But I'm going to set the length to be 20. So I'm going to set the length relatively small. I'm going to add the field. Now, what I'm going to do is I'm going to do a calculate. So I'm going to calculate from rivers, river name, and I'm going to give it a Python expression. So I'm going to try to calculate it equal to name. This is a Python expression, so that's why I'm closing that field here in exclamation marks. Now, I'm going to hit enter. Red text, so something failed. So the row contains a bad value. So if I look at my attribute table now, I see river name was added, and it partially did a calculate. So what happened here? So if I look at this value, I can see it's larger than 20 characters. So it couldn't populate it here because the field's not large enough. So, now I got to go ahead. I got to go and delete my field. So let's go and delete this field. Now, if I were doing this in an edit session, what would happen? Let's take a look at that. So I'm going to clear this, and I'm going to say, I'm going to use a with statement. So with arcpy.da.editor. And the editor requires the workspace as an input here. So, because the feature class I'm trying to update is in this workspace as edit. Colon. Now what I'm going to do is I'm going to do my arcpy.management, which is the data management toolbox. So every toolbox is a module in arcpy. And I just prefer accessing the tools this way. And I'm going to say, okay, I'm going to add a field to rivers called river name. It's going to be a text. And I'm going to set the length to 20. Next, I'm going to do calculate field. And I'm going to do it on rivers. I'm going to be doing this on river name. And my expression is going to be name. Python. Now, I'm going to hit enter. Okay, it added the field. It did do the add field line, but when I got to a calc, an exception was raised. Now, what happened in this case? If I go over to my table, I can see the field is not there, or the partial calc. Because what happened was, inside the with block, the edit session was started, the operation was started, and it added the field, but then it encountered a failure, an exception. Okay, an exception was encountered, so it did its cleanup on the on-exit and said, okay, we're going to stop our editing and not save our edits. So now you can see how that can benefit you. Okay, now let's look at another example. Here I just got some random shapes. Okay, these features don't represent anything, but we use it in our testing. So what I want to do, actually a couple weeks ago, someone from our defense department contacted us, and they're using 10.0, and they wanted to actually update or insert into two feature classes in the same geodatabase. So the same file geodatabase, they were trying to do multiple inserts on multiple feature classes. Well, it was failing, it wasn't working. And that's because you can only do one insert. You can only edit one feature class at a time there if you're not in an edit session using our insert cursor. So let's look at that. I'm going to load a script here that says insert features, no edit mode. So in my table of contents, I have my polyFC. If I turn that off, and what I'm trying to do is I'm going to try to copy the polygons into a new feature class and all the points that represent those features into a point feature class. So if we look at the code, I'm opening up a search cursor on our polyFC. Then I'm trying to open up two insert cursors, one on the points, one on the polygons. And then I'm going to start walking through the search cursor and try inserting those geometries. Right? So I'm going to try in the polys, I'm just going to insert row because I actually have the full geometry back. And then for points, I'll actually walk through each polygon, get each part. For every part, I'll get its points and try to insert the points into the point feature class. So let me hit enter. Right away, I get an error. It says workspace already in transaction mode. This error is coming from that second insert cursor line, because the first one opens, then it tries to open another one and says, no, it's already in transaction. So let's clear this. Let's load a different script. Insert features edit mode. So what I'm going to do here is I'm going to use an editor. I'm going to start an edit session. And I'm going to do the same thing. Oop, I know what wrong there. So let me just do this. I'll rerun it. Delete points. I'm not doing any clean up here with my cursors. I should have them in width blocks. But let's reload this. Fresh. And there you can see that because I'm in an edit session, now I can actually update multiple feature classes from that workspace. So, yeah, I'm using a with statement for the editor, but I could also use with statements with the cursors if I wanted to. With the search cursor. So, but you can see here now, at 10.1, what this person wanted to do in our defense department is now possible with Python. So for now, we had to do a workaround and make sure he just updates each feature class at a time. One at a time. Dave, that's back to you.
Yeah, to kind of follow on that line of thought, a few weeks ago I was working with a guy in-house, and he had a sort of a tangled script that was basically trying to take earthquake data. And
Actually, go back to me one
sure.
second. I want to show something.
Okay, well, let me finish. Yeah, he had like a tangled web of feature classes and relationship classes and all sorts of things, and he was opening a search cursor and doing the old insert and search cursor to pull the data out of these files and stick them into the feature class, and it just wasn't happening, right? It was sort of very confusing and invisible on what was happening. So, I looked at his code for a few minutes. We just stuck in the editor class, put in a new cursors, and then it worked. And then, not only did it work, but we reduced his code by about 50%. So, the editor class really does get you through a lot of hurdles. Right.
Okay. Well, thanks, Dave. I
just
wanted to show one more thing. We showed using the editor inside the with block and how it takes care of things for you. But perhaps you want more control. Perhaps you want to be able to start the edit session, have the decision to either stop or save the edits. So you don't need to use a with block. So if you were to create you could create the editor as arcpy.da editor, give it the workspace. And in this case, you can use the edit object in to do start editing. And then you could start an edit operation. And then you can perform some updates. Let's actually zoom in on the river. What I'm going to do here is I'm going to try editing this river to make it closer to the county boundary. So let me just go over here and copy in these 2 lines of code. Control-C. And I'm going to do a densify and a snap. So I'll densify it. Oh, I did it on the wrong feature class, but that's actually, let me do this, remove this. I did it on the wrong feature class, so let's start over. Say it. I'm going to delete the edit. Say edit, stop editing. False. Real quick. Clear this. Just hit my up arrow. Let's start again. Start editing. Start an operation. And instead of the river edits, let's use Crow River. So it's going to densify this blue river, blue line here, snap it. So you can see that, it snapped to the boundary in a lot of places, but not quite everywhere. So what I could do is I can say, well, I wanted to undo that. So I'm going to say edit.stop operation. So if you've worked with the arc objects before in the editor, stop your operation, and then you can do edit.undo operation. If I refresh, you can see it undoes those changes. So you have finer control outside the with statement. Stop editing. And I'm done. So I just wanted to show you that, so you could do it either way if you want more control this way.
Better? Yeah? Okay. It all sounds the same with me up here, but I can look see in the crowd and see the difference. But all right. So one other area that we've added to the arcpy data access module was another set of list functions. Of course, we have a whole pile of list functions right under arcpy. But there was a number of sort of workflows that couldn't really complete in Python because we just didn't have enough information about things like domains and replicas, subtypes and versions. For some of these things, you get some of the information you needed through the describe object, but really wasn't all there, and it was really sort of hindering a number of workflows. So yes, we've added list domains, list replicas, list subtypes, and list versions, and these all return objects except for list subtypes, which returns a dictionary, right, of properties. That's really all I have to say with that. I'm going to let Jason go back to showing how all that works.
All right. So I've been working on some projects. Oh yeah, I forgot. Okay, so I've been working on some other projects this past year where I needed to get at more of the attribute domain information on a geodatabase or get the subtypes from a database. And I discovered, well, that information isn't there. We did have a list versions and a list domains, but all it gave you back was the name as a string. Well, that wasn't much good because what I wanted to do is I wanted to compare geodatabases. I wanted to copy the domains from one workspace to another. And I wanted to do this all in Python. Unfortunately, for the 10.0 project, I had to do it in arcobjects and deliver it that way. But we worked hard in the last few months, and we just got this into 10.1 before we go final. So we thought it was a good place to put this on our data access module. So let's first look at this geodatabase here. We look at the properties. It has some domain information. So it has a coded value domain, has a range domain, and another coded value domain. So what I want to do is I want to look at the properties of that in Python. Well, we go out to our resource center now that we have launched at 10.1, Python Resource Center, and I go to my Python recipes. I search in domains. I actually have a code snippet now that out there that shows you how to get the properties of all the domains on a workspace. So I'm actually going to copy that to my clipboard. And I'm going to go over here in the Python window and I'm going to paste it in. Now, I know this path isn't correct. This is just for the sample. So delete that. And I'll drop in this Boston GDB in this other location. So what I'm doing is I'm listing all the domains. So I'm getting a list of domains. And then for each domain, I'm going to walk through. I'm going to print out its name. I'm going to print out its type. or check its type. If it's a coded value, I'm going to say, okay, well, let's print out all the values. So the coded values come back as a dictionary, a Python dictionary. And then for value and description in the coded values, I'm going to print those. If the domain is a range, I'm going to print the min and the max of that range value, the domain. So let's hit enter. And you can see here I get all that information now. So the domain name was just no. Here's its value and description. Domain name seasonal, its value and description, and then the domain of the range domain. I get its min and max. So these are things now that you can actually get at. So let's clear this. Let's look at, so if you look at this new geodatabase, City of Boston, I have no domains. So what I want to do is I want to copy all the domains from this GDB to this GDB. So I'm going to go ahead and load a script called copy domains. What this is a function. So I define a function here that's going to copy domains from the input workspace to the target workspace. I have some, up front I have some dictionaries here, which are the split policies or merge policies that will be used in our tools for creating domains. We do have GDB tools for creating domains and then assigning those attribute domains or range domains to them. So I'm going to get a list of my domains, and I'm going to start walking through each one. If it's a coded value, I'm going to create that domain in the target with the domain name, its description, its type. Well, in here it is coded. I know because I'm in this block that it's coded value, so just hard-coded that. And then I just look up the split policy in the dictionary I created up front, and I create it. And then for every code and description in the coded values, I'll use another tool called add coded value to domain and add those coded values. Else, it's a range domain. So I create a range domain, and I set value for range domain. So we have a tool for that. So let's define our function. Now let's actually call this function. So I'm going to say my input workspace is the one containing the domains, comma, my target. Get you at the end there if I can. Just drop you in. You can see over here, it's running. And if I go back now and check my target, I have my coded value, my range, and my other coded value. So this is stuff now that you can do in 10.1 that you couldn't do before. Clear? I just want to show you one more thing. If I look at one of these feature classes, the boundary here, if I look at the properties, it does have a subtype field, and you can see the codes and you can see the descriptions. So I can now get at this information. So I can say subtypes equals arcpy da.list subtypes, and here you can see all the list functions. Domains, replica, subtypes. And I'm just going to say pass in the table. And I'll print subtypes. Now you can see I have a Python dictionary of the code and its description. So if I looked up one of those, by code, I have yard waste pickup. So this is something else that's new at 10.1 that wasn't possible before. So now you can get this information into a nice dictionary, and you look up the values pretty easily. And that's all I have.
All right, the last major part that is the arcpy data access module was some more support for Numpy. Is everybody familiar with Numpy on at least some basic level? All right, well, Numpy is a third-party Python library that we add to the Python installation that we put down. The biggest part of Numpy is that it has this powerful array object, and really everything that we talk about today is taking something from inside ArcGIS, putting it into a Numpy array, and then pulling it back in. And in addition to the array object itself, the benefit to Numpy is that it has a really rich library of analysis capabilities. Now at 10.0, we already started down this road a little bit, and we added the ability to take rasters to and from NumPy arrays. At 10.1, we're now adding feature classes and tables to that as well. So there's in the arcpy data access module, we have a set of 5 functions. You can convert feature classes and tables to a NumPy array, one for each, and then there's a function to take it back. And then we also have an extend table function, which works sort of like a join. So you have some array, done some analysis on it, you want to bring that back, you don't have to create a fresh table, you can just join it on with a common ID to your existing data. So here's sort of a simple example. In this example, I'm using the feature class NumPy array, and I'm taking an input feature class, just counties here, and specifying a couple fields. You'll note that the structure to the feature class NumPy array and actually search cursor is actually pretty similar. The arguments are largely equivalent. So running feature class to NumPy array with 2 fields, and that generates this array. And then once I'm in Numpy, which my array is, then I can do something like get the correlation coefficients of 2 fields from that array. So array and the field name, that's pulling out just one column of the array and comparing it to a second column in that array and punching out some correlation coefficient numbers. On the flip side, then you can take whatever you've done in Numpy and then bring it back in. So on top, I'm just sort of creating this really small, tiny array for demonstration purposes, but it has basically 2 columns, an integer value, 1s and 2s, that's represented here. And then the second one, there's a column with 2, so it's a column with a tuple inside of it, and that's just x and y coordinates. I'm just describing a template to get a spatial reference, because in Numpy, of course, right, it's just a giant table, right, an array. There's no real spatial information, obviously denoted. When you're working with rasters, of course, it's sort of implied, right, because a raster and an array have a very similar, structure, right? It's just grid, rows, and tables. With a table or a feature class, I need to reassign my spatial reference coming back in. So bringing in my array, I'm assigning it a feature class name. I'm providing fields, this x, y. That'll push that to the shape, and then a spatial reference to position it correctly. All right. So if I just started map, now the one thing about Numpy arrays, right, is it's all in memory, right? So that's part of what makes it really efficient. You don't have to worry about writing all these pieces out to disk and getting the values back. It's all in memory. Just something to consider. If you're like in here, if I'm in a Python window and I'm just magically creating all these arrays, especially on big data, right? That's just going to eventually balloon out. So just something to be careful with. So if I wanted to, say, just take this streets feature class and dump it into an array, I could specify a couple of fields. And of course, you need to assign that. All right, so that'll dump it out into a Numpy array. So if we wanted to see the array, you can type it in, give a sort of a condensed view of it. So you can see I pulled in 2 fields, and then at the bottom, this is just the data type for Numpy, how those columns are basically defined. If I wanted to, say, just get a part of the array, arrays support indexing, right? Slicing. So here I can just get the very first row of that array. If I wanted to do something like grab just one of those columns, I can use specify name, and that'll just take that particular column and bring it into a new array. if I want to do some simple analysis on any array, so here I'll just take that, that miles, and there's a whole series of methods off of an array object that you can do for future analysis. So if I just want to get a total sum of that, just use a sum function. Actually, that's somewhat similar to what you were doing with the cursor. Now, like I had earlier in that one slide, there's more than just methods off of an array object. Numpy supports a whole series of methods that come right off of Numpy. So in this case, I just have a simple feature class of the states of the United States with a little bit of demographic information attached to it. So I'm going to export that to a Numpy array, and then I'm going to pull out just a couple of fields from that. So this is average household size and median age. And then on the bottom, I'm going to take that array, and I'm going to take out the average household size and the median age, and I'm going to put it into the Numpy correlation coefficients function to see how that relates. So of course, you would, as average age would increase, you would expect that household size would decline, right? Less children overall. So you should expect a fairly low negative correlation, and that's what this number here suggests here. So I created this function to do a little bit of sort of this basic stats for myself. So what I want this function to do, and it's going to use a lot of Numpy, is going to get some statistics from a table. So I'm going to provide an input table, an output table. I'm going to get do some statistics on a particular field from that table, a statistics type, and then a case field. So I'm going to start off by pulling that information out of a GDatabase table into a Numpy array. That's what it does here. I'm going to pull in that stats field and that case field. Then I'm going to create a small unique array. So I'm using the Numpy unique function to take that array with the case field and get every unique value. And then here, because Numpy sort of pre-allocates the memory for an array, right? It kind of creates the whole size, and then you work with that. So if you want to insert information, you usually don't insert like a new row into a Numpy array. You create the whole thing and then insert into existing positions. So the stats array will represent what I'll have at the end. And I'm just going to enumerate through that unique array. The array had all my unique values, and I'm going to do some basic statistics. So this is a long line. Let me try and explain it in parts. So right here, this returns an array of Booleans. So true or false. So each row that matches my unique value in the original array will get a true value, or false if it's something else. If you look at all of this together, when that array is matched back against my original array, it'll return an array that includes only those rows that had true. So suddenly I've created a smaller array that's just a subset of that unique value. You look at it with this, that returns only the one field, the statistics field, and then I've added just the method on the end to summarize it. Now I did it this way. There's an alternative, and it's a little more complex, but you can use Python has a built-in function called getAttr to basically use a method but pass it in as a string, right? So it doesn't read as nicely, but if I wanted to condense this down, otherwise I'd have to write, one of these for every statistics if I can, or, that I had it or wanted to use. Down here, I could use this in place of all those statistics types, in place of this huge chunk right here. Then down here, because Numpy arrays are a function, they're not as concerned with overwriting data, so you need to check whether or not your output exists. So I'm just checking if my data exists, deleting if it does, and then I'm going to use Numpy array, the table function, to create that. So if I let this run, the window down below, when it gets going, it should print out all the unique values and then create a table. Okay. And if I wanted to see that, all right, so I did some basic statistical analysis in Numpy from what was originally GBase feature class. Did a bit of little statistical work there, and then exported it back in. So, yeah, Numpy really has a lot of stuff out there, and it plays nicely with a few other third-party libraries out there, like SciPy, for instance. So there's a lot of potential for a lot of interesting work to happen inside Numpy, sort of as an intermediary with ArcGIS tables and feature classes. All right, that went just a little bit faster than I was expecting, but I wanted to just highlight a couple of resources that are out there. Of course, now at 10.1, we now have we'll have like a dedicated Python resource center. So historically, if you wanted to find Python information, you really had to go through Geoprocessing. Now you can find it directly through the resource center, a Python resource center. And we also have a Twitter account where we provide updates from time to time. All right. Any questions?